Hello there, we're going to carry on our work on A Level Maths and in particular looking today at statistics and trying to find the standard deviation and the variance of a sample of numbers. Now this is a bit weird because certainly not on the GCSE exam, so we need to be able to find the standard deviation and the variance. So let's show you what I mean by this. Now first of all we've got a starter. So it says a table below shows the number of brothers and sisters for a year 13 class. The idea being that there are 3 students in the class who had no brothers or sisters. There are 5 students in the class who had 1 brother or sister, and so on and so on. So a quick starter, just see if you can answer these questions. And this is really just basic GCSE maths. How many students are there in the class? Number 1, or B. Now, what is the mean number of brothers and sisters? The mean, of course, is another word for the average. You should know how to find the mean. So what's the mean number of brothers and sisters for members of this class? And what's the median number? This is a different average. Median is usually the middle number once you put them in order. So see if you can do that. Pause the video and I'll restart it once you've done it. Okay, so hopefully you've got some answers. I'll go through the answers now. So how many students are in the class? So that's actually relatively straightforward to do. You just add up these numbers here. So 3 and 5 is 8 and 2 makes 10. 13, 14, 15, 16. I think there are 16 students in this class. Now what's the average? You might remember doing this at GCSE. You ended up kind of saying, writing this as X. This is F, and you had to do an X times F column or row, depending on how they were laid out. And the idea of this is, look, these 3 students have no brothers and sisters, any of them. So between them they had none. So 0 times 3 is, and you just times. 0 times 3 is 0. But these 5 students had 1 brother and sister each. So 5 times 1. In total they had 5. And this is what we just keep doing. We've got 2 students with 2 brothers and sisters. They've got 4. We've got 3 students with 3. So that makes 9. We've only got the 1 student with 4 brothers and sisters. That makes 4. And we've got 2 students with 10. So 2 5s. 2 with 5, 2 5s are 10. So I add these together to get the total number of brothers or sisters. 5, 9, 18, 22, 32. There we go, quite a nice number. And what's the mean number then? I do that 32 and I divide by the number of students in my class. Now I reckon there's a lot of you who didn't do that. I reckon there's a lot of you who added up all the numbers and divided by 5 or maybe 6 or something daft like this. And the answer is 2. And if you think about it, if you were told at the start that the average number of brothers and sisters in this class was 2, and of course the lowest is 0, it goes up to a maximum of 5, you think, yeah, 2 sounds about right. What's the median number? Well, this is when we're meant to put them all in order, and it's the middle one. So notice it's a bit more, it's obvious once you see it, but there are 3 students, I said, there were no brothers or sisters. So I'm just going to write 3 noughts representing those 3 students. We've got 5 people with 1 brother or sister. So I'm going to write 5 ones. Now I have to say this is not the best method when you've got lots of numbers. I've got a relatively small number of numbers here. I've got 16 numbers. I've got 2 2s. I've got 3 3s. I've got 1 4 and I've got 2 5s. And now if I try to find the middle, you might remember crossing off on both ends. So you definitely try to do this in pairs. So you notice I've done that 1 and that 3 and then my mind has stopped. And now I'll do this 1 and this 3. Then I'll do this 1 and this 3. This 1 and this 3. That's interesting. I've got 2 different numbers there. I've got a 1 and a 2. So when you get that, you have to say 1.5. Halfway between those 2 numbers. That's what I got. Yeah, 16, 2 and 1.5. So there are the answers. So why standard deviation? Why am I talking about standard deviation? Well, I will just tell this story then. A boy needs to travel to school every morning by bus. He has a choice of 2 bus companies that he can use. They leave from opposite ends of his road, with both claiming to leave at 8:10. He suspects, however, that they may sometimes be late, making him then late for school. Presumably they take up the same amount of time to get there. So he decides to test the claims of these 2 companies. Being a good mathematician, he went on 10 days to both bus stops and timed how long he'd have to wait for each bus. And his results were as follows. So here are his results. And you can see the easy bus, he had to wait 0 minutes. Well, this is the number of times they were late, wasn't it? The amount late. they were, so 0, 2, 1, 11, and so on and so on. And then the comfy bus, which is 2, 3, 1, 5, and so on and so on. So your job is to calculate the mean time that he has to wait for both buses, and then which bus should he catch. So the mean times, just add them up. So if I just add them up, 0, that's 2, 3, 14, 17, 18, 19, 20, 30, and a couple of noughts. So the first one is 30, and I think it's 10 times it says, so it's 30 divided by 10 is 3. So he has to wait an average, a mean time for this bus of 3 minutes. Let's do the other one. I've got 2 and 3 is 5, 6, 11, 14, 16, 20, 22. Would you believe it? It's the same. 30 divided by 10 is still 3. So in actual fact, there's no difference in the mean time. But I'd still ask the same question, which bus should he catch? I'll think about it for a moment. If that was you, which bus would you go and catch? Would you catch the easy bus? Would you catch the comfy bus? Or doesn't it make any difference? Now, right, this is what my thinking. I wouldn't catch this bus. The easy bus, I'd say to myself, no, I don't like the look of that. And it's because there are some times which are really late. Now, there's lots of times where it's hardly ever, not late at all, but there's some times when it's really, really late. And that might be the difference of me being late for school. Whereas this bus, it's never, in fact, it's never on time, but it's never very late. The worst it ever is 5 minutes late. You can see usually it's 2, 3, 1, 5, 3, 2, 4, 2, 4, 4. It's broadly, always, predictably, a couple of minutes late. Well, 3 minutes late. So I would personally catch the comfy bus because it's more reliable. And this idea of reliability, or less spread out data, is what I'm getting at here. So it's never very late, and it should always get you to school on time. Now, what I'm saying here then is it's no longer enough to consider the mean as sufficient to describe which is best. And here it's the measure of a spread of the data that I've used. It's how spread out the numbers feel. Now we are expected to be able to find the variance and the alternative, which is the square of the standard deviation. So I'll just write this formula here. The variance that we're going to have to be able to find is equal to what I'm going to call the standard deviation squared. So you're going to have to square the standard deviation to get the variance, or put it a different way, you'll have to square root the variance to get the standard deviation. So let's look at the two methods, and there's basically two methods that I need to show you for the exam. So number one is the formula. Ooh, doesn't that look pretty? And there's actually a second formula as well. There you are. I'll go through those formulas for you in a bit. You might want to write them down. Now try to write them down exactly right. Don't half write them down. But to be honest, that's not our preferred method. Our preferred method is to cheat and use a calculator. And our calculator, our class whiz, I took a photo of my class whiz after I did a question. And you can see here it tells me certain things. That says that x bar equals 58. It says sigma x equals 522. Now as that happens, this x bar is this thing from here. It says sigma x. Well, that's this thing here. And if you go down, it tells you sigma x squared. It tells you n. It even tells you sigma x. That's this one here. So this, by the way, is the standard deviation, which I've been talking about that we need to find. So our calculator will tell us lots and lots of stuff if we let it. If we're able to use it, I suppose, is another question. So I'm going to try and use the calculator on this question. It's a tennis player, and on this question it says the weights of 10 tennis players are measured in kilograms, and those are the 10 weights of the 10 tennis players. And it says use the Casio class width. So the very first thing I'm going to have to do is talk you through what you've got to press on your calculator. So let's just go over here. So on this calculator, now you've got to turn it on, obviously, and I'm going to tell you what buttons to press. You're going to press mode, and I'll write this down as I do it. You're going to press mode, and then you've got to press the button which is, well, it's number 6. And if you press 6, it says statistics on the screen, and I press enter. And then it gives you a choice of a variety of different variables and modes within the statistics, and you choose one variable, which is number 1. And it should come up with a, well, it says X probably. Now I need you to also now do something else. I need you to press Shift and Setup. So over here, I'm just going to write that. What we're about to do, you're only going to do once. But once you've done it, it's useful. Shift Setup and press the down key. And then it comes up 3 statistics. Press that. And it says frequency. Do you want it on or off? And you want to press 1 on. And I suspect yours at the moment says off. And when you turn it on, you'll notice a difference. So I'm pressing 1, and it's gone back now, and I've got on my screen almost like a frequency table, X and freak. And that's useful because I can now, whenever I enter numbers and they're in a frequency table format, I can just type them in and say how many of each I've got. But actually on this particular example, all I'm going to do is I'm going to type in 94 and the 87, these numbers up here, type them all in a list going down. So 94, 87. And I have now typed them all in. So the next stage is to, now you have to press effectively the Option button. And if you press the Option button, which is written OPTN, it comes up with a number of things, and you're going to choose 3, and it says 1 variable calculation. So I'm pressing 3, and it comes up with all the things I want. So the ones I want to write down from this are sigma x. Now I know it says other things, but just for now, right, sigma x is 898, and the other thing I want is n. Well, n actually we know is 10. And we also want sigma x squared, which is 83706. So it's taken a while to get there, but those are the things that I'm after. And we're going to use them now to calculate some stuff. So I can find x bar. Now the calculator actually tells me what x bar is, but I'm going to show you can just do this. And once you're given this, what we call a summary statistic, 898, we can divide it by 10. I'm just using this formula here. And that gives me 89.8. Now on the top of your screen it should say 89.8. That's what the mean is. This is the symbol for the mean. So I now know the mean is 89.8. And if I want the standard deviation, that symbol is sigma x. And again, it says it on the calculator, but we'll do the calculation. It says sigma x squared, which I've just written down as 83706. It says divide by 10, because that's what n is, and then take away x bar squared. Now x bar is 89.8, so I've got to 89.8 squared. So I'm going to do that now on my calculator. So it's the square root of a fraction 83706 divided by 10 minus 89.8 squared. And I get some horrible decimal, but if I press the SD I get 17.5. 17.51 I suppose. That's my standard deviation. And you can't quite see this here, but it does agree, it says 17.5. So we've got it right. X bar equals sigma x over n. Now I should point out what this sigma x means. It means the total of all the numbers that you have in your sample. So that's the total of all the numbers. Obviously n stands for the number of numbers that you have. I'll just write that as well, number of numbers. Now the second thing that you have is this, which I'm saying is sorry. Just get rid of that. The second thing that you have is the formula for the standard deviation. And this is, it looks a horrible formula, it probably is, but it's not as bad as it first seems. So sigma x squared over n minus x bar squared, all square rooted. So this sigma x squared over sigma x squared is the sum, or the total if you prefer, the total of all the numbers. But notice what you do is you square them first. You square each number and then you total them up. So every number you square it and then add it together. Square it, add it, square it, add it. This is still the number of numbers. This is the mean that we found up there. So that's the mean from here. As I say, this is the standard deviation. There is actually a third formula as well, which I at some point need to show you. But for now, these will do. So let's go on to the next question. Now this question, now look, this is a really nice question because notice they give us all the values. Now, in the last example I did, even though I had all the values, I deliberately didn't use them. But from now on, our general rule will be, if they're stupid enough to give us all the numbers, we're going to type them into our calculator. That's why here it says use your class whiz calculator to do it. So again, let's get this set up. So we press menu and we go to 6. So again, I'll just write over here what you have to type in, menu 6, and one variable, and then 1. And then it should come up with the table that we made it always come up with last time. So now you enter the numbers. Again, it comes up with X and frequency. And you just enter these numbers going down here. So I'm going to type in 229, 217, etc. Dot, 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 dot. So you do the same things. Okay, I've done mine. So now if you remember, I told you to press Option. And then you press number 3 for the calculations. And it comes up with everything you want on the screen. Now mine comes up. What's it asked me to find? It says find the mean. Well, the mean you need to know is X bar. So that on my calculator it says 219.875. Now it wants it to 3 sig figs. So I'm not going to give it quite that accuracy. I'm going to pretend it's not 219. In fact, it's not even 21, because to 3 significant figures, I reckon that's 220. What else does it want? So I've done the mean, standard deviation. So the standard deviation, you look on your screen and it says sigma x like this. And mine says 7.59. There's a load of zeros after it, but 7.59 is what I'm writing down. So I've done the standard deviation. The variance, now what you need to know is the variance is 7.59 squared. So you might want to type in 7.5, well, you might want to use a different calculator actually, because otherwise you'll lose what's on your screen. We'll come back to that in a bit once we've written everything else down. Oh, the interquartile range we want as well. Now the interquartile range you might remember from GCSE is the upper quartile minus the lower quartile. Now if you scroll down in your calculator, it has got on it what it calls the Q1, the median, and the Q3. So these are the values that we're going to use. The Q3 is the upper quartile. It's 226.5. And the lower quartile is 213. That's the Q1. And if I take one away from the other, I reckon I get 13.5. It just tells us, it just lets us do it. I'm going to, at this stage, press all clear. And I'll need to press menu and 1 to get back to the calculator mode, the normal computational mode. And I'm going to type in 7.59 and square it. And I get 57. Now it won't be precise. 57.6. It won't be because I've rounded it, but it probably is close enough. Let's see what my answers were when I last did them. So 220 I got, 7.59 I got, 57.6 I got, and 13.5 I got. So it's worked out. And our calculator will tell us everything we need to know. Here's another one. No, notice this one though. It says number of people who travel by taxi to work in the morning in 2001 was found in 10 local authorities in the northeast. Here are the values in the summary statistics. So it's how people get to work, and it's the number of people travelling in these different local authorities every day in the northeast of England. And I've given this summary statistic, and it tells me to use the formulae. So even though they've given me this, it very particularly says use the formulae. So I better use them if I'm going to get all the marks for this question. So I've made some space. These are the formulae again. So okay, we're going to have to do it. So first job is to always find the mean, x bar. And the formula says sigma x over n. That's 5960 divided by n. It's 10n, which is 596. So on average, 596 people travel by taxi every day. Second job, find the standard deviation. I assume it said find the standard deviation. Yes, it does. Sometimes it says find the variance, you see. So standard deviation sigma x equals, now it's the square root of, and you should show this working out, 4370746 divided by 10 minus the x bar squared minus 596, what we just calculated, squared. So I'm going to type that into my calculator. So it's the square root of a fraction 4370746 over the 10, and then minus the 596 squared. And I get 286.1. Now it probably said to 3 sig fig, so probably roughly equal to 286. And that is the standard deviation. So the answer, well, actually after all that I wrote 286.1, but you can see it's right, and 596 is right as well. So as a general rule, look, our first plan is always, when we get these questions, if it says find the standard deviation, our first thought is, can I use the Casio class widths? Can I use the calculator? Because I know it will be easier. Now if they let you do that, i.e. they tell you the actual numbers, the actual values in the question, then you just type them in. And unless they specifically say use a formula, you should just type them in. But sometimes you're not able to do that. They don't actually tell you the actual values. Sometimes they tell you the summary statistics, and by the summary statistics they will need to tell you n equals whatever, they'll need to tell you sigma x equals whatever, and they'll need to tell you sigma x squared is equal to whatever. If you get told these things, then you will be able to use a formulae. And there's no way around that. If they don't tell you actual numbers, you have to use the formulae. So bear that in mind. I want you in lesson to have a look at exercise 16B. I'm only suggesting certain questions at the moment, and we'll see how that goes. So thank you very much.